Good morning and good afternoon, everyone. Welcome to our second in our series of three winter storm stories. Today, we are focusing on ice storms. My name is Andrea Berg, and I will be your host for today. And I am joined by Brad Nelson, one of DTN's meteorologists and risk communicators. He will be leading us through our webcast. Before we begin, I just wanted to let you know everybody is muted. We are recording this session, so if you would like to view this again or pass this on to a colleague, we will be sending out a link to the recording in a few days after this session ends. So with that, I'd like to turn this over to Brad. Brad?
All right. Well, thanks, Andrea. Appreciate the introduction here. Welcome to the next in our session series of winter storms, and this one's going to be on ice, freezing rain, and how that impacts utilities and what kind of mitigation procedures we can do to, help prepare for that type of risk before and during and after these type of events. So with that, let's talk about a storm that occurred in late January into early February of early this year. And it was a long duration ice storm, freezing drizzle, sleet type of event it was called Winter Storm Mara at the time. And it occurred across the south central United States all the way into the Tennessee and Ohio, southern Ohio valleys, actually. So a large system, a long duration system, multi-day event that had significant impacts on the utility grid across the region, unfortunately. So what we had was a strong cold front driving its way south through the southern plains and into these areas where it collided with warm advection, warm, moist air from the Gulf of Mexico overrunning this front. And when that occurs, you get very cold air at the surface, warm air aloft. So what happens is you have rain falling onto below freezing air and surfaces at ground level, and that instantly creates ice. So this was a very significant event. There was an inch of sleet. These are just a few examples of what occurred. Inch of sleet in Tulsa, freezing rain in Arkansas, Missouri, Illinois, and as far south, it's a pretty significant event for the Austin area and San Antonio, Texas. Um, in fact, there was actually a Dallas Fort Worth International Airport had sleet accumulation and a little bit of snow up to 1.3 inches through this event, which caused significant impacts and delays there. That was a record for that date, actually, of all time. And the airport was below freezing for 88 hours. And an example in Granbury in Hood County, they were below freezing for 111 hours through this event. So it took a while for all of this ice and sleet and snow to melt. We had quarter inch to up to 3/4 of an inch of ice accumulated in parts of the region, specifically from the Austin area up through northern and northeast parts of Texas is where these most significant ice accretions occurred. In fact, the 0.71 inches of ice buildup in the Austin area was a record for the date. Brought down tree branches onto power lines, power poles themselves, and led to over 350,000 total without power through this event, and 160,000 of those alone were in the Austin area itself. Universities closed, businesses closed, everything was shut down. The U.S. Postal Service prides themselves on delivering mail through, snow, sleet, ice, whatever. They had to suspend operations in North Texas on the last day of the year. Or I'm sorry, of January of last year. So that's rather significant. On February 4th, as things were winding down, the governor of Texas issued a disaster declaration for a 7-county area and caused over $89 million in damages. and total of 563,000 power outages. And unfortunately, there were 10 deaths attributed to the storm, mainly with car accidents that occurred. So this was a very large storm area. We had freezing rain reports here are in the triangles in the sleet reports are in the triangles, freezing rain reports are in the squares. The darker colored squares down here in central and northeast Texas, that's significant icing that occurred over half to 3/4 of an inch. On the right, you can see the expansive area of cloud cover, low clouds, the moisture moving in from the Gulf of Mexico with strong southerly flow, overrunning the cold front that stalled out across the region. And then essentially you had overrunning precipitation that was freezing at ground level there. So here's the look at the observation field that specifically temperatures and the radar overlaid on that. Pretty large area of light to moderate precipitation, most of this freezing rain on 9 a.m. on February 1st. The area circled in red, everyone here was at or below freezing, and obviously that led to major ice buildup across the region. On the right was the watches, warnings, and advisories that were in place. Very large, widespread, expansive areas of either winter weather, winter storm warnings, or ice storm warnings that occurred here. All right, so what did this create? You know, widespread power loss. There was power lines down. You know, big restoration effort, obviously, that needed to be undertaken. Transformers coated in ice many, few days even after the event in Dallas itself there. And this is, this is interesting. Here's a power line coated in ice accretion here that either was brought down by the ice or more than likely by this branch that this gentleman, this crew member is picking up here and clearing to restore power. But it's interesting. It's not only the power loss that we need to think about with these type of events. It's the hazard conditions for the utility workers out there as well that are attempting to repair the damaged equipment itself. It's challenges getting around. Road surfaces make it challenging for crews to get to the affected areas. There's a risk of accidents and injuries, and the communication as well. So you need to ensure communication with your crews, and a lot of that can be disrupted as well due to these major ice events. There's another look at power pole that was snapped on the left here due to the weight of the ice and some wind. This significant weight on the power lines and the poles can cause them, unfortunately, to snap or collapse, and this results in extensive damage to the infrastructure and takes quite a bit longer, obviously, to restore power when this type of damage occurs. In addition, on the right, you have power outages. Just a snapshot on February 2nd of the over 200,000 customers without power at the peak of the outages, and this was primarily in the Austin metro area, according to the power outage .us here. So. All right, here's a look at, just wanted to show you, a look at what it looked like from a standpoint of the radar and how that occurred. But you can see the overrunning type of precipitation from the 6-hour period. Oh, let's go back to that. From a 6-hour period, and get it to move. A lot of sleet and ice down in Waco, College Station, and then how it fills in across the Dallas, Fort Worth area. So just this is a 6-hour duration, and when you have that long duration type of freezing rain event that occurred, leads to significant damage. All right, so the ice storms, they lead to accumulation, ice accretion on power lines. Some of this can add hundreds of pounds of weight, a half inch a quarter to a half inch of ice accumulation on lines and poles can add up to 500 pounds of additional weight, add in a little bit of wind, and that's can bring down this infrastructure distribution lines as well. So typically how this happens is you have freezing rain onto the lines, and if you look at the right, the ice accumulates around the line and then down in a teardrop type of shape. If you add a little bit of wind to that, this creates major issues, and the actual wires can sway wildly. The wires can collide and actually can bring down poles if the winds are strong enough and switching direction. Um, Ice obviously increases the weight of the tree branches as much as 30 times, and then adding the wind brings down the weight of the trees. Brings down the tree branches onto the lines, leads to outages as well. And that's why it's important, for utility customers to, be out there and do vegetation management throughout the warm season and into leading up to the winter season to get ahead of, potential weak branches, foliage that you can take care of ahead of time to alleviate, these issues that might occur. So here's a look at, hopefully this works, but here's a look at line galloping. An example of that, see the lines swinging wildly here, and the actual pole is rocking back and forth. And if you get enough weight on the lines, the poles, with enough wind, you can understand how this pole, if it's weakened, can eventually snap and be brought down. All right, so how can, what are some of the tools out there to help mitigate risk, understand your situational awareness, what's coming, get ahead of these type of weather concerns? How do you prepare for this? We have a storm risk dashboard. These are some examples of a tool that shows you information about key windows based on your weather concerns, your custom thresholds. Here's several examples I've set across North America and a few across Germany. This is a global tool, but you can set up multiple locations, or you can cover your entire service area and then see the actual hazard windows. On the left here, you see a few locations I've expanded windows, the actual hazard types, and then with each individual hazard, the exact timing that it is expected to reach and exceed your threshold, your custom thresholds of concerns. And this is utilizing our DTN forecast engine for this type of information as well. So not only visually displaying the hazard windows with 7 days of coverage and hourly data, but also being able to be alerted on forecast weather conditions for your concern. Just want to show a quick look at how we customize alert thresholds. In this case, for freezing rain, ice accretion for 1 hour, snowfall, wind. This could be, I'd recommend setting these thresholds based on your infrastructure and different areas of the service territory. So obviously, you're going to have a lot lower thresholds for ice and wind, some generally in parts of the southern U.S., whereas maybe northern U.S. or northern Europe might have a little bit stronger infrastructure to handle these type of these events. So these can be customized. I've set a few up here and to be alerted on. But it really lets you focus on what matters. All right, the action points, the key trigger points here. You set these thresholds. When it reaches them, you have to take this type of action, or you need to start calling in crews at this point, or reach out for mutual assistance when we reach a certain threshold with ice and wind on the lines and the infrastructure. So I think that's really important to get ahead of it. And it's a holistic view of weather risk. This is an example. About a week and a half ago in Europe, there was an icing event, freezing rain event that was going to occur. Overlay key weather information on the map. This is radar with my location underneath, color coded by precipitation type, red being ice. And in this case, we had, you know, a period of icing and high winds in the forecast. And generally, where those overlap, you're going to have your biggest concern. Agency warnings in here, along with observations and the hazard timeline and the DTN weather forecast, all in one view. And so you can get a view. You can get a holistic view of what's actually occurring, what's going on. And these are good for like big board displays, and getting an understanding of exactly what is occurring now and what is likely to occur in the future in the forecast. And this was an interesting example about how we support uh, points, lines, or polygons. In this case, polygons, I set up alerting around, I called it Miltenberg. This was a city in southern Germany that was being impacted by freezing rain. But I set up my service territory, so my whole region, and then the lines, the alert thresholds are set for the entire service area instead of just looking at one point or several points across your region, whether that be um, a small city or municipality up to state level and even country level as well. Also wanted to highlight today our storm risk analytics. This is really interesting, where we take county data information, bring that into our solutions, and then overlay our DTN weather forecast on top of that. So we're using data to understand how many outages are likely to occur on a county level. This is primarily across the United States at this time, but it shows you a baseline and then a prediction for, in this case, day 5 on the left for Cook County, Illinois, and then on the right here for out near Seattle for an event. This was a high wind and ice event that occurred. You're in the yellow. We had a baseline of 416 outages normally on this day. On day 3, prediction was over 1,600 outages in this case. So this gives you an idea generally about what kind of outages we're going to see on a spatial scale, overlaying weather information onto the data. In addition, there's many ice risk mitigation solutions for utilities, many steps that utilities can take to understand not only what's coming, but how many outages are going to occur across my service area, when to utilize crews, sign crews, and when it's weather conditions are going to get better, and it's big for safety as well. Um, Storm impact analytics, uses machine learning, actually AI, to understand our utility customers' data, and then overlaying weather on top of that. With AI, we can understand the magnitude, the severity of outages for you. So as population grows, we're going to see accountability grow, expectations for faster power restoration increases, and so a lot of these grid resiliency investments that we're talking about in point 2 here, they're really important, right? You got to think about not just the short-term costs that might be undertaken, but the long-term costs that would, help saving costs in the long term by building underground lines or stronger materials. And, the costs associated with repairing, replacing damaged infrastructure, deploying personnel, getting mutual assistance, and implementing these preventative measures can have significant financial implications, obviously. And these costs can be typically passed on to customers through rate adjustments as well. And I know that utilities just generally want to try to avoid that. Um, and with some of these, competing for resources, you need to get ahead of this early. That's why utilizing prediction tools well ahead of time, utilizing meteorologists and risk communicators to get ahead of weather and the impacts that might be occurring in your service territory is very important. Resources, especially if you got a large scale ice storm, freezing rain event, like in this case, you're going to be competing for that. It's going to be resources stretched thin. Neighboring utilities, they're handling their own problems. They may not be able to assist your restoration issues as well. So that's obviously quite important um, thing to consider. So with that, just wrapping it up here. Thank you for joining. Just this real quick discussion on the storm series and this one on this significant freezing rain event and impact on utilities. I appreciate it very much. If there's any follow-up questions, myself, my expert team of meteorologists, we'd be glad to get back to you. Any kind of technical weather questions, utility impact questions, feel free to reach out. We're here for you, and we'd be glad to either have a conversation or answer any type of email questions. My LinkedIn profile name is on there as well. I'm on there. I'm active. Be glad to connect and answer any questions there and have a discussion. So thank you very much, and I hope everyone enjoys the rest of their Tuesday.